Welcome to ZICA Academy YouTube channel. In this lecture, I want to examine the special form of single limiting factor. Special form of single limiting factor. If you are coming across my lecture for the first time, please like the video, share it with others, and subscribe so that you don't miss my upcoming videos. If you are a returning subscriber, I say thank you for being part of this channel. So in my earlier video, I've examined single limiting factor, where only one resource constraint is given. Although I've said in that video that you may be given two or more potentially limiting factors, of which one of it will actually be limited. Only one of the potentially limiting factors, that is, if you are given more than one, only one of it will be a constraint. Take note of that. But in this special form of single limiting factor, you will be having two or more resources constraints. Therefore, special form of single limiting factor is where the organization is facing more than one constraint, and yet linear programming is not required to be used. Remember, I've told you in my earlier presentation that where the constraints are more than one, then that means you are expected to make use of a linear programming. If you have watched my earlier video on linear programming, you will understand how to solve linear programming. So, constraints, I've told you they are the factors that hinders the level of production of an organization. The factors that limit the level of operation of the organization. I've told you that the constraints are usually given in form of the available resources. So you may have the limited machine hours, or limited labor hours, or shortage of materials, or limited materials, shortage of demands. All those may constitute a constraint. Then, what are the differences between the special form of a single limiting factor and linear programming? Since the resources constraints in both cases will be more than one. So, the difference between the special form of a single limiting factor is that in special form of a single limiting factor, only one of the products will be produced. Only one. If you are given two products, you'll be required to produce only one, not both. You will be required to produce only one. And the production of that one resources, or the production of that one product, must be made in full, not in part. So that is the difference. But for a linear programming, both products must be produced, and the product can be produced in part. Remember, one of the assumptions of linear programming is divisibility. Divisibility in the sense that you can manufacture or produce the product in part. But in a single limiting factor, out of two products in question, only one of it will be required for production. But in linear programming, both will be required for production, but you can produce them in part. That is for linear programming. That is the difference between the special form of a single limiting factor and linear programming. Then what are the steps for solving the special form of a single limiting factor? Steps. Number one, you identify the constraint. Identify the constraint. So I've told you the constraint will be more than one, where the problem involves the special form of a single limiting factor. Why then do you need this step? You will need this step to be very sure that the problem involved is a special form, not a single limiting factor we have examined in my earlier video. So if you identify the constraint and you find out that the constraint is only one, then you are expected to pass through the procedures given in my earlier video. But if the constraint is now more than one, then you proceed to the next step. You proceed to the next step. Step number two, calculate the contribution margin. Remember contribution margin, CM, contribution margin. That is selling price less variable cost per unit. This will give you the contribution margin. That is, you can calculate the contribution per unit. Or you have your total contribution divided by the budgeted sales. So step number 3, then you choose the list. Determine the units of each of the products that can be produced with the available limited resources. Determine the maximum units of each of the products that determine the maximum units of each of the products that can be achieved with each of the constraints. That is, each of the available resources. That is step number 3. Then you choose the list of the results obtained in step 3. Choose the list of the production of each of the products. Choose the list. List means the smallest of the production of each of the products in step 3. In this step above. Choose the list of the production of each of the products in step 3 above. So I remember in step 3, I've told you that you should determine the maximum units of each of the products that can be achieved with each of the constraints, with each of the available resources. So when you do that, then you now go for the list. So remember, all the constraints will simultaneously be required for the production. So that is why where all the constraints cannot be satisfied, then that means you cannot produce the units of that product. Step number 5, calculate the expected total contribution. Calculate the total contribution from each of the products. Your total contribution, that will be the number of units you have obtained here, multiplied by your CM. Your CM is step 2. That is your step 2. Your CM is step 2 times the number of units chosen in step 4. The list you have chosen in step 4, you multiply. That will give you the total contribution. Then whichever product that have the highest total contribution, you recommend in favor of that. Step number 6, recommend the product. Recommend the product with the highest total contribution. The product with the highest total contribution. These are the steps you need to solve. You need to follow when solving problems involving special form of single limiting factor. Now I want to take a question as work example. Keep watching. Example: Tenco Limited produces 2 critical components, K and T, both of which are used in petroleum refinery. The components are made by passing each one through 2 fully automatic computer-controlled machines, lines A and B, with respective maximum capacity of 13,600 hours and 15,360 hours. The following other details are available. 1. Due to production constraints, the company has decided to produce only one of the 2 components, K or T, for next period, but not both. 2. Market demand is limited to 59,200 units of K and 80,000 units of T. 3. Products unit data we have for K and T. Selling price 900 naira and 800 naira for K and T respectively. Machine time in hours for line A is 0.25 for K and 0.15 for T. Line B is 0.20 for K and is 0.225 for T. Raw materials X in kilogram, 2 kg for K and 2 kg for T. 4. The maximum quantity of material X available is 136,000 kg. The material is purchased at 50 naira per kg. 5. Variable machine overhead for machine line A and line B is estimated at 500 naira and 600 naira per machine hours respectively. 6. The company operates a JIT system required. A. Calculate which of the components K or T should be produced and sold in the year in order to maximize profits. You should state the number of units to be produced and sold and the resulting contribution. B. Tenco Limited wishes to consider additional sales outlets which could earn contribution at the rate of 400 naira and 600 naira per machine hours for machine line A and line B, respectively. Such additional sales outlets will be taken up only to utilize any surplus hours not required for the production of the components. Calculate whether Tenco Limited should now produce either component K or T and what quantity to be produced and the resulting contribution. A linear programming model which incorporates the data given in part A and B of the equation has shown that where Tenco Limited is willing to produce and sell both components, K and T, and use any spare capacity for the additional sales outlets detailed in B above, the profit maximizing means is the production and sales of 34,000 units of each type of components in the year. Prepare a budget analysis showing the total machine hours and material X in kilogram required for each component type and in total for the above production or sales mix. The budgeted contribution for each type of the components and the total budgeted contribution for the company in the year. That is the question. This question is obtained from Workout Performance Management by Adim Omoleyiwa. Now let's have the solution to the question. Solution. The first step is to identify the limiting factor. I've told you that the limiting factor is usually given in form of the available resources. Now back to the question. You were told that line A and line B respectively with maximum capacity of 13,600 hours and 15,360. This is the available line A hours and this is the available line B hours. So we want to confirm if this line A hours is a limiting factor. Confirm if the available 13,600 hours, if the available line A hours of 13,600 is a limiting factor. So we want to confirm if this 13,600 will be enough to meet the demand. Back to the question. You were given the market demand of 59,200 units of K and 80,000 units of T. And line A hours available for K is 0.25 hours per unit. This is the line A hours required to achieve a unit of K, and the line A hours available to achieve a unit of T is 0.15. And remember, the total available is 13,600, and these are the demand, 59,200 and 80,000. So line A hours, line A hours. We have for K and for T. Demand for K is 59,200 units, and the demand for T is 80,000 units times the hours required to achieve a unit of K is 0.25. And for T, we have is 0.15 hours. $59,200 times 0.25. That gives us 14,800. 14,800 hours. For T, we have 80,000 times 0.15. That gives us 12,000. 12,000 hours. If you sum it up, you have 26,800 hours. This is line A hours required. And the available line A hours available is 13,600. If you require 26,800 for production and only 13,600 is available, that is to show that there are no sufficient line A hours available for production. Therefore, you have a shortfall. 26,800 minus 13,600. That gives us 13,200 hours. That is a shortfall. Therefore, line A machine hours is a limiting factor. Then the available line B machine hour is 15,360. We want to know if that will be sufficient to meet the demand. So confirm if the available line B hours of 15,360 is a limiting factor. So you have two products, K and T. Demand remains 59,200 and 80,000 for K and T respectively. 59,200 and 80,000 units. And how many line B hours will be required to achieve a unit of each of the products? Back to the question. The available line B hour for K, the required line B hours for product K is 0.20 hours per unit, and is 0.225 hours per unit for product T. So 0.20, 0.225 times 0.20 hours times 0.225 hours. So how many hours will be required for the production? For K, you have 11,840 machine hours. For T, 80,000 times 0.225, that gives us 18,000. If you sum it up, you have 29,800. Therefore, line B hours required is 29,800. And the available line B hours available is 360. 15,360. The available is not up to what is required. So you have a shortfall of 14,440. So shortfall. Since you have a shortfall, the available is not enough for the production. Therefore, line B, machine as is a limiting factor. It's a limiting factor. So, and you also given the available materials. The maximum quantity of material X available is 136,000 kg. Let's confirm if this will be available. Confirmation. If material X is a limiting factor. So you have two products, product K and product T. So to achieve a unit of K, you need 2 kg of material X, and that of T, 2 kg as well. So we have 2 kg, 2 kg times demand. The units demanded is 59,200 units for K and 80,000 units for T. So 59,200 times 2. That gives us 118,400 in kg. 2 times 80,000, that is 160,000. Required what is required is 278,400. And what is available is 136,000 kg. So what is available is not up to what is required. So we have a shortfall. So we have shortfall of 142,400. That is to show that material X is a limiting factor. Step 2. So we calculate the contribution margin. Calculation, calculation of contribution margin. That is, we want to calculate the unit contribution. And there are two products. We have product K and T. Product K and T. So, and contribution is selling price less variable cost. Selling price. And how much is the selling price? So, back to the question. You are given selling price for K, 900 naira, and T, 800 naira. 900 and 800 naira for K and T respectively. From the selling price, we subtract the variable cost. So the variable cost includes material, raw materials, F, 2, we have 2 kg. This is in kg, not in naira. So you will need it in value. So we have material X, material X. And how much does the material cost? Material X in kg, 2 and 2. And we were told the material is purchased at 50 naira per kg. So we have material X at 50 naira per kg. So 2 kg for K times 50 naira. That gives us 100. Then for T, 2 kg as well times 50 naira. That will be 100 naira as well. In note 5, you were told variable machine overhead for machine line A and line B is estimated at 500 naira and 600 naira per machine hour respectively. Since it is per machine hour, you will need to multiply by machine hour. So variable machine overhead. You have variable machine overheads. So for line A, we have line A and line B. Line A 500 naira, line B 600 naira. So line A, line B. So back to the question, how many hours is required? So for line A, we have 0.25 for K and 0.15 for T. Line A, 0.25 hour. For B, we have 0.15. Times how much is the estimated amount? 500 naira. So multiply by 500 naira. So 0.25 times 500. So we have 125 naira. Then times 500. So 0.15 times 500. So we have 75 naira. For line B, we have 0.20 and 0.225 for K and T respectively. So we have 0.20 hour and 0.225 hours. And the amount is 600 naira times 600. 0.2 times 600. So we have 120. 0.225 times 600. So we have 135. So if you subtract the variable cost from the selling price, you arrive at the contribution margin. $900 minus 100 minus 125 minus 120. So we have 555. 40, we have 800 minus 100 minus 75 minus 135. Then we have 490. That is the contribution margin. Step 3. Determine the number of units of each of the products, number of units of each of the products that can be achieved. That can be achieved with the available resources. Now you have product T and product K. These are the products. So you have demand. The number of units of product K demanded is 59,200 and 80,000 units of T were demanded. So we have 59,200 and 80,000 units, demanding units. Then the constraints we have include machine line A, machine line A. So, the available machine line A hour is 13,600 hours. And to achieve a unit of K, you will require 0.25, and to achieve a unit of T, you will need 0.15 of machine line AR. So with 13,600 available, so that means for K, 13,600 hours divided by 0.25 being the hour required to achieve a unit of K. 13,600 divided by 0.25. So we have 54,400. Machine line A for product K is 0.25, and that of product T is 0.15. Product T, so 13,600 hours, 13,600 hours divided by 0.15. So that gives us we have 90,667 units. 90,667. So now let's put units. All these figures are in units. They are in units. Therefore, machine line B. Line B. The available machine line BR is 15,360 hours. 15,360. 15,360 hours. How many hours is required for the production of product K and product T? Line B hours required per unit. For K, we have 0.20, and for T, we have 0.225. So we have 15,360 divided by 0.20. That gives us 76,800 units. For T, 15,360, the hours required per unit is 0.225. So we have 15,360 divided by 0.225. That gives us 68,267. 68,267 units. 267 units. Then we have materials. Available materials is 136,000 kg. And to achieve a unit of either product, you will require 2 kg of material X. So we have 136,000 divided by 2 kg. Then you have 68,000. Same for the other one. 136,000 divided by 2, which is 68,000. I want you to know that the maximum unit of either product that can be achieved is the least of the results obtained. We are going to choose the least. Why? Why the least? For this is the demand. For K, to achieve a unit of K, the available machine line A hours of 13,600 will be sufficient to produce 54,400 of K. Then the available machine line B hours will be sufficient to produce 76,800. If this will be sufficient to produce 76,800, there are no enough machine line A hours available to be able to produce 76,800. That is why we cannot go for this. Though there are sufficient machine line B hours available, but the machine line A hours available will only be sufficient for 54,400. You cannot produce this. You have sufficient material for this. You can produce 68,000 units with the available materials of 136,000 kg. Then there will be sufficient machine line A hours for that, but no sufficient machine. There are sufficient machine line B hours available for 68,000, but no sufficient machine line A hours available. So that means you cannot produce more than 54,400. The same principles applicable to this. So optimal production plan. For A, you can produce 54,400. I've told you, you go for the least. Then for B, the least is 68,000. So you can, for T, so you can only produce 68,000. Though machine line A will be sufficient to produce 90,000. Machine line B will be sufficient to produce 68,000. But there are no sufficient materials to produce beyond 68,000. The available material can only produce 68,000. But you cannot extend your production beyond 68,000 because you don't have sufficient machine line A and line B. You have sufficient machine line A and line B, but you don't have sufficient materials to produce beyond 68,000. That is why you will go for 68,000. So now, that is all about that. Now, let's go back to the requirements. You have to calculate which of the components K or T should be produced and sold in the year in order to maximize profits. So you now determine the maximum contribution and make your recommendation on the basis of the total contribution. Now, let's calculate the total contribution. You have calculated the unit contribution for each of the products. So with this unit contribution, you multiply it by the demand, then you get the total contribution. And when you get the total contribution, you go for the product with the highest total contribution. Total contribution now. Calculation of total contribution. For K, so the contribution margin is 555 times the optimal production plan is 54,400 for K. 54,400 units. So if you multiply that, so we have 555 times 54,400. Then we have 30,192,000 for T. So the contribution margin is 490 multiplied by the maximum demand, 68,000 units. 68,000 units. That will be 490 times 68,000. So we have 33,320,000. Product T has the highest total contribution. So we go for product T. Back to the requirement. Calculate which of the component K or T should be produced and sold in the year in order to maximize profit. So component T should be produced and sold. You should state the number of units to be produced and sold and the resulting contribution. So product, let me say component T should be produced and sold because it's the number of units to produce, number of units of component K or component T to produce is 68,000 units. Then total contribution from that will be 33,320,000. So that is the solution to the A part of the question. Then B, Tenco Limited wishes to consider additional sales outlets which could earn contribution at the rate of 400 naira and 600 naira per machine hour for machine line A and line B, respectively. Such additional sales outlets will be taken up only to utilize any surplus hours, not required for the production of the components. So that means you will need to determine the surplus hours. No, after the production of the number of units required, then how many hours of machine line A will be left, and that of machine line B. I calculate the surplus hours not required for the production of the components. So surplus hour calculation of the surplus hour. Surplus hours not required for the production of the components. So we have two components, component T and component K. So we have two machine lines, or let me just say let's have machine line A and line B. So available are now for the machine line A we have 13,600, and for line B we have 15,360. 13,600 hours and 15,360. Now, hours utilized in the production of component K, the machine line A hours utilized. Remember, to achieve a unit of a line of K, you will require 0.25 hours. And to achieve a unit of T, 0.15 hours is required. So we have 0.25 for K, 2.5 for K. Then for line B, is 0.20 hours is required. 0.20 hours is required. How many units of product K were achieved? Now, we were told the optimal production plan for K we have 54,400, and for T we have 68,000. So for K now, 54,400. So we have 0.25 times 54,400. That gives us 0.25 times 54,400. That gives us 13,600. 13,600. And for line B, we have 54,400 times 54,400 times 0.20. That gives us 10,880 hours. Now, surplus are not utilized. Surplus hours now. So 13,600 minus 13,600. So there is no surplus hour for line A in the production of product K. For line B now, the surplus are 10,880 minus 15,360. Then you are left with surplus hours of 4,480. 80 hours. That is the surplus hour. Then for product T now, product T. Then the available hours still remains 13,600 for line A and 15,360 for line B. 15,360 for line B. Then hours utilized. So now to achieve a unit of T, 0.15 hours is required. And to achieve a unit of T, you need 0.225 of line B hours. This is for line A hours, while this is for line B hours. So we have 0.15 hours for line A, and for line B we have 0.225. And what is the maximum production that can be achieved for for component T? We have 68,000. So we have times 68,000. 68,000 times 68,000. So you have 0.15 times 68,000. Then you have 10,200 hours. That is the hours utilized to achieve 68,000 units of component T. Then for the other one, we have 0.225 times 68,000 times 68,000. That gives us 15,300. 15,300. 15,300. If you subtract 15,300 from 15,360, you'll be left with surplus hours of 60 hours. 13,600 minus 10,200. Then you have the surplus hours of 3,400. That is the surplus hours for component T. Now, if you go back to the question, the requirement B, you were told that Tenco Limited wishes to consider additional sales outlet, which could earn contribution at the rate of 400 naira and 600 naira per machine hours for line A and line B, respectively. You will expect a contribution of 400 naira for line A hours and contribution of 600 naira for line B hours. Such additional sales outlets will be taken up only to utilize any surplus as not required for the production of the components. Any surplus as not required for the production of the component. That is what you are going to utilize the additional sales outlets on. So now you want to calculate whether Tenco should now produce either component K or T and what quantity to be produced and the resulting contribution. So now let's calculate the contribution, calculation of the required contribution, required total contribution. So remember, you have two components, T and component K. Component T and component K. And the contribution from component T is 33,320,000. I have rubbed off the contribution from component K. So that of T. This is K, this is T. Initial contribution for component T. You have contribution of 33,320,000. 33,320,000. 320,000. The contribution from component K, which have been rubbed off, I think we have 555 times the unit of 54,400. So we got 30,192,000. So if you go back to our solution, this figure have been calculated as the total contribution from component K, and this was what was obtained as the contribution from component T, and that is still on the board. Now, contribution from the utilization of surplus hour. Utilization of surplus hours. Then there is no surplus hour for line A machine. Line A machine, no surplus hour. Line A for K, no surplus hour. But for T, line A, we have a surplus hour of 3,400 for component T. Component T, 3,400. 3,400 times how much is the contribution expected per unused surplus hour? You were told Tenco Limited wishes to consider additional sales outlets, which will contribute at the rate, which will earn contribution at the rate of 400 naira, 600 naira per machine hour for machine line A. That means line A is 400 naira. So we have 3,400 times 400 naira. So 3,400 times 400, that gives us 1,360,000. 1,360,000. Then for line B, we have for component K, we have the unused surplus hour of 4,480. 4,480 hours. Contribution from the unused line B machine hour is 600. Therefore, we have 4,480 times 600. That gives us 2,688,000. 2,688,000. If you add it to 30,192,000, 30,192,000, that is totaled 32,880,000. The contribution pass unused surplus hour is 600 naira. So we have the unused surplus hour for component T in line B, that is 60. So we have 60 hours times 600. That gives us 60 times 600. So we have 36,000. 36,000. So let's sum it up. 36,000 plus 1,360,000 plus 33,320,000. And this is totaled 34,716,000. Component T still have the highest contribution. Therefore, Tenco Limited should produce component T. So the units of component T that should be produced, quantity of component T that should be produced, remain 68,000 units. That is the solution to the B part of the question. You were told a linear programming model which incorporates data given in part A and B of the equation has shown that where Tenco Limited is willing to produce and sell both components K and T and use any spare capacity for the additional sales outlets detailed in B above, the profit maximizing mix is the production and sales of 34,000 units of each type of components. Remember, we have two components. We have component T and component K. Component K. You have sales or production mix. Mix of 34,000 units of either 34,000 units, either product. The sales and production mix remain 34,000. You have to prepare a budget analysis showing the total machine hours and materials required. Now, let's calculate the machine hours required first. So remember, 2 machine hours is required. Machine hours required. Let me put total. Let me include total. 34,000 units and total. So 2 machine hours is required. We have line A and then line B. How many hours of line A is required? For line A, to achieve a unit of K, you need 0.25 and 0.15 for T. So we have 0.25 times, if the production mix or sales mix is 34,000. You have 0.25 times 34,000. That will be 8,500 hours. 8,500 hours. Then for component T, 0.15 times production and sales mix of 34,000. That will be 0.15 times 34,000. Then that will be 5,100 hours for component T. Now, what will be the total machine hours required for both products? 8,500 plus 5,100 plus 8,500. That is totaled 13,600 hours. So, remember, the available line A hours is 13,600. That is to show that machine line A hours is fully utilized. There is no surplus hours unused. Then for machine line B, so you have 0.2 for K and 0.225 for B. Now, 0.2 times 34,000 being the sales and production mix. Then 0.225 times 34,000, which is the sales and production mix. 0.2 times 34,000, that gives us 6,800 hours. For T, 0.225 times 34,000, that gives us 7,650. Now, what is the total machine hours used? 7,650 plus 6,800. That is totaled 14,450. So, if you look at the available machine line B hour is 15,360. And what is used is 14,450. That is to show that machine line B hour is underutilized. So in this case, there will be an unused machine line B hours. Now back to the question. So we've done with machine hours. Then material S in kilogram. So material X in kilogram. Then material X. To achieve a unit of K, 2 kg will be required. And to achieve a unit of T, 2 kg will also be required. So you have 2 kg times 34,000 being the production and sales mix. That will be 68,000. Then for T, 2 kg times 34,000 units being the production and sales mix, that will be 68,000 units. 68,000 plus 68,000. That gives us 136,000 kg. And the available material X is given to be 136,000 kg. That is to show that material X is fully utilized. There is no excess material X unused. Back to the question required for each component type and in total for the above production or sales mix. The budgeted contribution for each type of the components. What is the budgeted contribution? Now, contribution is sales. We've calculated the contribution margin. So, budgeted contribution. From, if you go back to the working tool, we got contribution margin of 555 for component K. 555 times sales mix of 34,000. 34,000. So we have 555 times 34,000. That gives us 80,870,000. 80,870,000. Then for component T, we got the contribution margin of 490. Go back to the step 2 where we calculated the contribution margin. You will see this figure there. I've rubbed off that part of the solution from the board. So 490 times 34,000 units. So we have 490 times 34,000. That gives us 16,660,000. 16,660,000. So we've gotten the contribution for each type of the component and the total budgeted contribution for the company in the year. Total budgeted contribution now. Total budgeted contribution for the year. You add the two contributions. You add them together in order to get the total. 16,660,000 plus 80,870,000. Then we have 35,530,000. 35,530,000. Then after this, remember, we have the unused line B hours. I've told you that line B hours was underutilized because the available of 15,360 is greater than the one used in production. Then contribution from the unused machine hour. Contribution from unused line B machine hours. Remember, available of 15,360 minus what was used of 14,450. So we have 15,360 minus 14,450, which was used. 14,450. That will give you the unused machine hours. Machine line B, 15,360 minus 14,450. Then you'll be left with 910 hours. Then how much was the contribution earned per unused machine line B hour? Tenco Limited wishes to consider additional sales outlets, which could earn contribution at the rate of 400 naira, 600 naira per machine hour for machine line A and line B. So the line B is 600 naira. So we have times 600. Times 600. 910 times 600, we have 546,000. 546,000. Now, if you add this to 35 million, 530,000 plus, 35 million, 530,000. So we have 36 million at 76,000. 36 million at 76,000. So, if you go back to the question, contribution for the company for the year. So that is the solution to the C part of the question. This marks the end of the solution to the question. Please drop the love emoji. Share the video with others. Like it as well. Thanks for watching ZICA.